Welcome back everyone. Today I'll be doing partial differentiation where I'll be differentiating composite function using partial derivatives. Now I'll be using chain rule once again, but this is a case 2. Here we have a function of x, y, s, and t. Case 1 is where we have a function of x, y, and t. Suppose that z is equal to a function of x and y, and its differentiable function of x and y, where x is equal to, it's a function of s and t, and y is also a function of s and t. And they are both differentiable functions of s and t. So this is a partial derivative. We have to differentiate z with respect to s. So I have to use chain rule, and I'll be showing how do we use this function. And here we have to differentiate, find a partial derivative of z with respect to t. And once again, we have to use chain rule. So here we have an example. For this example, we have if z is equal to e to the x sine y, where x equal st squared and y equal s squared t, we need to find the partial derivative of z with respect to s and the partial derivative of z with respect to t. To find the partial derivative of z with respect to s, what we're going to do, we are going to find the partial derivative of z with respect to x, then the partial derivative of x with respect to s, plus the partial derivative of z with respect to y, and the partial derivative of y with respect to s. Let's look at this. So to find the partial derivative of z with respect to s, I am going to differentiate z, but it is the one that has the x I will differentiate. The differential of e to the x is e to the x, so I rewrite e to the x. And because the sine y is attached to it, that's why I rewrite my sine y. Differentiate, finding the partial derivative of x with respect to s. This is in terms of x and s. Yes, we have a t, but we're looking for the one that have x and s. Differentiating x with respect to s, it means I differentiate s to get 1. So this is 1t squared, which is the same thing as saying t squared, plus finding the partial derivative of z with respect to y. So now I'm going to go back to this, but differentiate sine y. So differentiating sine y, I will get cos y. So I go ahead and write my cos y. And if you prefer to do it as how it is ordered, then it means I will just rewrite e to the x. So you can put e to the x in front, while others would put it behind. It really doesn't matter. So I differentiate, find the partial derivative of z with respect to y, and we differentiate sine y to get cos y and rewrite e to the x. Now differentiating this part, finding the partial derivative of y with respect to s, differentiate s squared to get 2s. So that means here I will have 2st. So that means what I have here is e to the x, t squared, sine y, putting this in front, so I'll have plus 2st e to the x cos y. Now to find the partial derivative of z with respect to t, this is what we will have. We will be finding the partial derivative of z with respect to x, so let me remove this. We've done this already, but I'm going to redo it. So differentiating this with respect to x, we differentiate e to the x to get e to the x, and then rewrite sine y. Then we find the partial derivative of x with respect to t. So looking at this, here's my t, differentiate it to get 2t, having my s. So that means I can write this as 2st. So therefore, right here, I will have 2st plus find the partial derivative of z with respect to y. So it means I differentiate sine y to get cos y. So I will have e to the x cos y. And the final part, differentiate y with respect to t. So looking at this, I differentiating the t, this becomes 1. So this is s squared. So I'll have a s squared here. So it means that what I have here, I can write this as 2st e to the x sine y plus s squared e to the x cos y. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have a question, you can leave a comment below or suggest a topic that you would like me to look at.